Hi all, Assalamu alaikum. Today we are going to discuss part 2 of the chemistry entrance exams. Let's start with the first question. The precipitate formed when barium chloride is treated with sulfuric acid. That is our 11th question. You have to remember an acid sulfuric acid would form the salt sulfates. If the salt is insoluble, we call precipitate. If the salt is insoluble, we call it as precipitate. Here, when you see the equation, the reaction between barium chloride and sulfuric acid, barium chloride is BaCl2 when reacts with sulfuric acid, which is H2SO4. This first will go with this second, and this first will go with this second. So it will form BaSO4 plus HCl. When you see the balancing, you need a 2 to put here to balance this equation. BaSO4, it is insoluble, so we put a state symbol S. All others are aqueous. That means they dissolves in water. Whereas barium sulfate does not dissolve. That's what this is the precipitate. So the answer here is BaSO4T. Next question. It's about the oxidation number. What is the oxidation number of chromium in K2Cr2O7? First of all, you have to understand when you add oxidation numbers of all the elements in a neutral compound will be 0. Okay, it's very easy to identify the oxidation numbers of some of the elements. If it's from group 1, usually they will have an oxidation state of +1 because they tend to lose their electrons in chemical reactions. And for group 2, they have 2 electrons in their outer shell. They tend to lose the electrons. That's what they will have a +2 oxidation state. Group 3, they have 3 electrons, so they always prefer to lose the electrons. So when they are losing electron, it will gain a positive charge. So 3 electrons would be lost, so it would form +3 oxidation states. It has the group 4 has 4 electrons, so it can either gain 4 electron or lose 4 electron to have an octet 8 electrons in the outer shell. For fifth group, usual oxidation state is -3. Already they are having 5 electrons, so they need to have 8 electrons to get stability. So 5 and gaining 3 electrons are negatively charged. So gaining 3 electron means 3 negative. Oxidation state of group 6, they are having 6 electrons, gains 2 electrons are negatively charged, so -2. Seventh group already having 7 electrons, just to need to gain 1 electron to get stability, -1, this is 0. This you have to remember. Now let us see this oxidation state. Potassium is from group 1, so it is having an oxidation state of +1. Chromium we don't know, so let's put X. Oxygen is from group 6, it's having an oxidation state of -2. So total must be 0. You have 2 potassium, so +1 times 2 plus we have 2 chromium, so 2x. Chromium we kept it as x, and oxygen has 7 -2 and 7 oxygen, so you can say -2 times 7 equals 0. So you can say +2 plus 2x minus 14 equal to 0. So 2x, when you rearrange, it is 2x is equal to 14 minus 12 is equal, sorry, 14 minus 2, that's equal to 12. So 2x is 12. So x is equal to 12 by 2, that is 6. So oxidation state of chromium is +6. 6 means +6. Next question is about Gain oxidation, you have to remember oil rig. Here they're asking which half reaction correctly represent oxidation. Oxidation is losing electron. You remember oxidation is losing electron. Reduction, on the other hand, reduction is gaining electron. So here you can just see over here this one. Chromium, it lost 3 electrons and became Cr3 plus. Always when electrons goes out, it will get positive charge. So chromium lost 3 electrons to become Cr3 plus. So this is the answer for this question. Let's see the next one. What is the pH of 0.0001 molar HCl solution? Well, this is a direct question. You have to just use the equation to find pH. pH is equal to negative logarithm of concentration of H plus ions. So here negative log 0.123401 is equal to. Let's take the calculator and do the negative log 0.00001. That's equals 5. So the answer is 5. So the answer over here is D. Let's see the next question. What type of reaction is CH3CH3, that is ethane, reacts with chlorine to form this product, chloroethane and hydrogen chloride gas? This type of reaction, when you see the structural formula for all of these, you will get a clear idea. Alkanes are not having double bond. They are having all single bonds so that they cannot undergo any addition reactions. Rather, they will undergo substitution reaction. See, one of these hydrogen will go with chlorine and the other chlorine will join here. This chlorine will take part of this. So this hydrogen will go out with this chlorine and this chlorine will come and join there. So chlorine is taking the place of hydrogen. So we call these kind of reactions as substitution reaction. See, this hydrogen gets substituted by chlorine and the other product is hydrogen chloride gas. So this is a substitution reaction. Alkanes, single bonds only, so they prefer to go under substitution reactions. This question is about Iupac naming. Iupac naming, you have to remember. The first step, you must choose the longest chain. When you count 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, either this way or this branch way would be fine. So we are choosing this. This is the longest chain here. 1, 2, 3, 4, 5 carbon atoms are there on this. Now the other ones we make it as we just keep them as branches. So CH3 branch we call methyl. CH3 branch we call methyl. This is a CH3 branch. Then this is also a CH3 branch. This we call methyl. CH4 is methane. So CH3 branch we call methyl. Now you have to number them, number these carbon atoms in such a way that side chains or these branches must get least number. Either you can start from here or from the other side. If you're starting from here, 1, 2, 3, 4, 5. If you're starting from here, you count 1, 2, 3, 4, 5. If you're starting from here, the branches, this branch is getting 3 and this branch is getting 4, 3, 4. If you're starting from this side, this branch is getting 2 and this branch is getting 3. So 2, 3 is smaller than 3, 4. So always we prefer to go for smaller numbers for branches. So it is 2, 3. Then methyl. There are 2 methyl group. So you can say dimethyl. Okay. and there are 5 carbon atoms. So it is pentane. So 2,3-dimethyl pentane. The answer is D. Next question. The hydrocarbon with a double covalent carbon bond are called. That you have to remember. Like if single carbon bonds, carbon single bond, we call them as alkane. If there are carbon double bond, we call them as alkene. And if there is carbon triple bond, we call them as alkyne. Okay. Now let's see an example. If 2 carbon atom with the remaining will be hydrogen. This carbon will have double bond. One carbon has a valency of 4. So the remaining you have to keep hydrogen. This is with 2 carbon, 1 carbon we call meth, 2 carbon we call eth, 3 carbon we call prop, 4 carbon we call bute, 5 carbon we call pent, and so on. You have to remember up to 10. This is 2 carbon atoms, so we can say ethane. Well, here there is a double bond between the carbon atoms, so 1, 2 had gone, total 4 valency for each carbon. So another hydrogen here, 2 hydrogens required. Here also 2 hydrogens required. So the formula is C3H6. Here the formula is C2H4. It's double bond, but 2 carbon atom, we call it as ethene. Whereas for an alkyne, triple bond. So already 1, 2, 3 had gone. Just 1 hydrogen is required to satisfy the octet. So 4 bonds must be present around carbon atom. So 1, 2, 3, 4. That's fine. Now C2H2 would be the formula for this compound. This is called ethyne. So remember, carbon double bond, that is always in alkenes. Next question. 2 isomers of saturated hydrocarbons. Isomer, the word meaning, it will have, this is organic compounds having same molecular formula and different structures. And different structural formula. That's isomers. So let's see an isomer for butane, C4H10. This is butane. It can be arranged like this: 1, 2, 3, 4 carbon atom in a linear chain, and all the hydrogen atoms. So this is one structure. Okay, this can have an isomer by putting a branch. Let's see here: 1, 2, 3, and 1 carbon down. So now it has got branched. So this is another compound. I mean, same molecular formula, but structure is different. This is called butane. Okay, this is called isobutane. If you look for the Iupac name, this is so propane with 2-methyl propane. So you just remember, they will have same molecular formula, but they will have different structures. Okay, have the same molecular formula. So 18, the answer is C. 19. The correct classification of for the following compound. You have to see here COO. If COOCH3 comes, they are esters. Remember, if there is a COO comes with the R group, any CH3 groups or any other groups around, that is called ester. Don't confuse it with the carboxylic acid. Carboxylic acids will have an H. You see here it is CH3. But if there is an H, then COOH, then this is a carboxylic acid. The other one is C double bond O with SCH3 groups on both the side. This we call ketones. The other one you will have a CHO. This is aldehyde. If you have this one, we call this as aldehyde. And if just OH, that is alcohol functional group. So here the answer is ester B. Last question. Glucose is a what? Glucose is the simple sugar. Simple sugars are monosaccharides. Okay, so glucose is a monosaccharide. The direct question. Okay, boys. So we'll see in next part, inshallah.